Okay, so we have studied what is data science, what are the various methods of data science, and we also studied what is the meaning of correlation, types of correlation, and last class also we discussed what is the meaning of probability, right? So we also studied different types of data sources that we can have, the data for the analysis purpose, the types of data that is qualitative and quantitative one, and we also described the various types of data analysis methods, right? So today we'll continue the probability distribution method so that we can know much more better about the probability distribution of the data, how the data is distributed if you consider the probability case, right? So as you know that yesterday we have studied about the probability, and I told you that probability means it is the chance, right? And the maximum value of occurrence of an event is 1, and the minimum value it was 0. So let's just share my screen. Okay. So this much we have discussed that probability it means the chance of getting something. So uh, let I am tossing a coin, and the what the total chance of getting the output is 2. That means it may be head, it may be tail. So if I ask what is the chance of getting, or what is the probability of getting head, if you are tossing a coin, that was 1 upon 2, that was zero point 0.5. That means the probability value you can get the fractional value or in percentage or in decimal point. And we told that the maximum value of occurrence of an event, that means most likely it is 1, and the impossible one, that means the minimum value, and means we cannot get any value beyond, or we cannot get any value less than 0 if we are getting, or if you are working with the probability. That means the minimum value of occurrence of an event it was 0, or the minimum chance of any statement can be 0, right? So the value of probability always lies between 0 and 1. So we get 0.5, 50%, 20%, 0.02, etc. That means the value should be in between 0 and 1. And we have already discussed the conditional probability. That means if there are two events A and B, and they are related with each other, then what is the probability of having A if B has already occurred? Or what is the chance of that A will also occur if B has already occurred? So that was conditional probability, right? So up to this we have discussed. Then next, see, the today's topic of discussion, it is a very important one, the types of distribution, that is normal distribution and binomial distribution, that is in your syllabus, right? So let's discuss this one. See, here it is the types of distribution of data in statistics. Means when we talk about the different types of data distribution in statistics, we generally come across two types of distribution. That is, one is called observed frequency distribution, another is called theoretical or probability types of data distribution, right? So this probability distribution is otherwise called as expected frequency distribution. Then what are these two? Let's discuss the first one. What is this? This is the observed frequency distribution. Means what? Whenever we are analyzing data, if the result is obtained by the actual observation, that is called observed frequency distribution, right? We are getting the result by the actual observation. We are not applying any formula, or we are not applying any probability to get the result. Then that kind of data distribution, or when we will plot those data or plot those outputs, we can tell that as the observed frequency distribution, right? Then what about this theoretical or probability distribution? That means if we are getting the result using the formula, or using formula we can find out the frequency, that means the number of occurrence of an event, then that kind of data distribution or that kind of data that we use in statistics, that is called probability distribution. That means if the result that is mathematically reduced under certain assumption, we call that as probability distribution. So there is the difference between these two types of distribution that is generally used. First of all, it is the data or the result is observed through direct observation, or here the data or the result is observed through the formula, right? So using assumption, using probability, using chances of occurrence, we have to deduce the formula using or deduce the result using various mathematical formulas, right? So this is the difference between these two. Then if you talk about, let's have a further discussion about the observed frequency distribution and the expected frequency distribution, right? uh, how many of you have joined? Let me check again. O- okay. Okay, that means whether they will join or not. Okay, sure. Okay, sure, no issue. See, then this is the example that I want to explain this observed frequency distribution. Okay, so you see that suppose we have collected data about the wages received by 80 workers. Okay, so we have just arranged the data in a tabular form that displays the wages in rupees received by 80 workers. That means you can see that the amount 100 is received by 5 workers, and these are the amounts received by the number of workers here. So here we can say that we are collecting data. We have collected the we have wrote the frequency in tabular form and collected the data. So this is called the observed frequency distribution, and it can be measured by the statistical measures. You can say we can use mean, we can use median, we can use mode, we can use standard deviation, all these things to measure the frequency of the data that is stored in a tabular form. That means we apply this method. This method means the mean, median, mode, standard deviation. These are the basic method that is used in case of statistics. We can apply these methods on the frequency distribution, right? So this type of frequency distribution, we can say that this is the observed frequency distribution. We are not using any kind of probability, we are not using any kind of assumption to find the result. We are observing, we are arranging the data in a tabular form. What we need the amount received by the workers in rupees, and we are just arranging the number of workers here. So as per the data present here, as per the method that we can need to find the minimum, the average wages received by the workers, we can also find out using the mean value. We can also find out the using the median value, the data that is required by us. So we are not using any kind of assumption, any kind of probability to get the value or to get the result. Okay, so that's why as we are observing the data that is stored in the tabular form from the original data we have, and we are not applying any kind of assumption to get the data, that is, this is called observed frequency distribution, right? So next you can see that the another table here, probability is used. In the first table there was no column of probability. We are not using probability, we are using the statistical methods to find the result if we need something. But in case of expected frequency distribution, which is called as probability distribution, also its other name, and we can also call it as the theoretical data distribution, we can find out the result at any position using the assumption, using the probability that is written. Okay, so let's see what is in this example. let we have four coins, right? Four coins, and it is these are touched 160 times. Then what is the expected frequency of getting a head? That means if we are tossing four coins 160 times, then what is the probability of getting head? We are not finding the actual data, we are finding the probability of getting the result. Okay, so that's why it is called expected frequency distribution. This is not the actual frequency distribution. We are expecting that this much can be the result. Okay, so that's why we are using probability data distribution. So here, what is the expected frequency of getting a head? Okay, so as the table you can see, these are the number of success. Number of success is zero, means if we are arranging a just putting a table where the first column is number of success. So if the number of success is zero, that means we are not getting a head. If the number of success is 1, that means we are getting a single head. So if the number of success is 2, we are getting 2 head, and this we are getting 3 head, and we are getting 4 number of heads. So these are called the number of success, right? Then probability of getting the head, here we are not getting any head, so it is probability is 1 by 16, 4 by 16, this much. This is the calculation one. Then what is the expected frequency of getting the head? That means now we will find that the expected frequency, it is not the actual frequency distribution, it is the expected one. So how can you get? We have to multiply 160, because we are tossing four coins 160 times, so we have to multiply 160 into 1 by 16 if the chances of getting head is 0. So then we'll get the result is 10. This is the expected result. So it will say that 10 times it will be when not a single head will come. Okay, so if the result is 40, that means it is 40 times that when a single head will come. Okay, so these are the expected frequency. So we calculated this frequency using the method or using the probability, right? So as we are not getting the actual value, we are getting the expected frequency, then it will be considered as the expected frequency distribution or the probability distribution, right? So here in this part, what did we do? That here we will find the expected frequency, it is not the actual frequency, it depends upon the probability. We are finding the frequency depending upon the probability. So what is the chance here? First, in first thing, what is the chance of getting head when there are, when we toss a coin, or when we toss four coins of 160 times? So in first case, we received the result, we received the expected value as 10. That means 10 times it will be when not a single head will come. And in second time it is 40 times, then when a single head will come. And the third one, it is the 60 times when two times head will come. And next, the result was 40, that means it is 40 times when three times the head will come, right? So this the result that we are getting here, this is the expected one, this is not the actual result. So we are using, we are making use of probability, so that's why it is the expected frequency distribution, right? Okay, so we can use this probability method, we can use this probability distribution method to make the prediction or to make the forecast. Okay, so if this is the value, what can be the other value, or what can be, or be the thing that can we get in the nearby future, or one from one thing, if you have the probability, we can infer any other things. So if you have the probability, it helps us to make the prediction also, to forecast also. We can infer one thing if we have something. Let we have this four coins are touched 160 times, then we just inferred, or we just predicted that what is the probability, what is the chance that only a single head will come, or what is the chance only the head will come twice or thrice, etc., right? So in this way we can expect the value, we can infer the value. So these are two types of data distribution, that is observed frequency, we are observing through the we are finding the result through direct observation, or we are finding the result through the probability. Okay, so in this way we can find out. Next, see, then when we are talking about the probability distribution, there are two types of probability distribution. First one is called discrete probability distribution. Second one is called continuous probability distribution. So probability distribution is generally of two types. So we will study actually the inner syllabus that there is binomial distribution and normal distribution that belongs to in these two categories. So in order to explain you all this distribution, I have to explaining what is the meaning of probability distribution, what is the meaning of original frequency distribution, right? Or the observed frequency distribution. So I think you are clear about what is the meaning of observed frequency distribution and probability frequency distribution. So let's talk about the probability distribution, that is of discrete probability distribution and continuous probability distribution. So if we categorize further, the discrete probability distribution is of two types, that is binomial and Poisson distribution. And in case of continuous probability distribution, it is categorized into normal distribution. So why I have discussed here only one, because in your syllabus you have binomial distribution and the normal distribution. So here the continuous probability distribution is further divided into normal distribution, and the discrete probability distribution is a binomial and Poisson distribution, right? So we'll talk about first the normal probability distribution. This is the very important one. In exam question generally come upon what is the meaning of normal data or the normal probability distribution, right? So difference between this and this. So let's talk about the discrete probability distribution. In case of discrete probability distribution, you know that the discrete value means the whole number, right? So 1, 2, 3, these are the discrete value. So if we talk about these discrete values and we'll plot these discrete values in a graphical way, we call that as the discrete probability distribution, right? So continuous distribution means that is in the decimal point. So if we plot the decimal points values in a graph, we can say the data is distributed, that is the continuous probability distribution, right? So the part of continuous probability distribution is called normal distribution. So in case of normal distribution, what happens, we can say it is a probability distribution that describes how the values of a variable are distributed. Okay, so what is the meaning of distribution of data? Whenever we assign a value to a variable, so if you are considering in our experiment, in our data analysis, we have so many variables, so we are assigning number of values to that variable. So if we are assigning the decimal value, that means the continuous values, and whenever we are going to plot the variables in a graph, we can say that if it is taking the shape of bell, okay, it's taking the shape of bell, that means if the bell shape curve is there, we can say that is the normal distribution of continuous data, right? So here the continuous probability distribution is called as the normal probability distribution, right? So you can see here normal distribution. As we know that normal distribution is a part of continuous probability distribution, that means the decimal points are to be plotted in a graph, and you can see that this is called continuous random variable. That means we can take the random variable, but the variable should be the continuous one. For example, weight and height. We say that I have 5.5, that means 5 feet 5 inch height. So this is a continuous data, and weights let I have 53.5 kg. That means this is the continuous variable. So whenever we want to plot the data in case of normal distribution, we have to consider the continuous random variables like weight and height, etc. So why this see the normal distribution is otherwise called as the Gaussian distribution or the bell curve distribution, because it was discovered by a English mathematician, that was Gauss. Okay. And according to his name, it was named after the Gaussian distribution. Okay, so it is further means manipulated by other mathematicians also. But as it was as whenever you are using the normal distribution, it will consider the continuous variables, and the variables should be collected randomly. Like, so whenever we'll plot the value of this randomly selected continuous values, then it will take a bell shape. So that's why its name is also called bell curve. Bell curve. It will look like this one. Suppose this is like bell shape. It will look like the bell shape. So whenever we plot the continuous random variable, it will look like bell shape, right? So let see, in case of this Gaussian distribution, or in case of this bell curve distribution that we also called as a normal distribution, it will look like this. As I told you, it will look like the shape of a bell. Okay, shape of a bell. So here, this is the mean value, this is the max value, and the middle one is the average value, right? The middle one is called the average value. And as you can see, if we draw a line, okay, if you draw a line, that means the values at the left hand side and the values at the right hand side, or you can see the area at the left hand side, the area at the right hand side are equally distributed. That means it is perfectly symmetrical and it is bell shaped. Whenever we plot the continuous random variable, it will give a shape of bell, and it is perfectly symmetric, because if this is the average one, this is the middle point, then the area at the left hand side and the area at the right hand side are perfectly similar. Okay. And at the peak point, mean, mode, and median are same. Okay. So mean, mode, and median of the data element that we plotted becomes same. So here is the point. This is the point where mean is equal median is equal mode. Okay. I think you know about what is mean, median, and mode. Mean means the average one. Okay. Average one. You know how to find out this. Then what about median? Suppose the values are, let the values are 20, 10, this is 40, and this is 30, and this is 90. Okay. So if you want to find out the median, first of all, you have to sort the elements, right? Sort the elements. So when you will sort the element, this will be 10, 20, this is 30, 40, and 90. Right? These are the values. Then find out the middle one. Then if we have 5 elements, the middle one will be this one. This is the middle one. So 30 is the median in this case, right? So you may have one question, that if there is another value, let 100 is there after 90, then what will be the median here? So when you will arrange this, you will get 10, this is 20, this is 30, this is 40, again 90, and 100. Okay. Okay. Then you can see these two are the middle value. Okay. So in means at the left hand side we are getting 10 and 20, at the right hand side we are getting 90 and 100. So these are the two middle values. So make the sum of these two values. So 30 plus 40 is 70, and divided by 2. So the median will be 35 in this case. So in this way you can find out the median. And if you say how can you find the mode? Mode means the maximum element. That means the element having the maximum frequency you have to select. So in this case, in this example, suppose let another example I want to take. Let it is 10, it is 20, let it is again 10, then 30, 40, again 10, and 90. Okay. Easily you can understand. Here, if you arrange the elements as per the frequency, we can see that 10 has occurred thrice, 3 times, 20 has 1 times occurrence, 30 has 1 times occurrence, 40 has one times and 90 has one times of occurrence. So what is the maximum occurrence of the elements? 10 has occurred thrice. So we have to consider that element as a mode which has maximum number of occurrence. So in this way you can find out mean, median and mode. So we are talking about the normal distribution. So in case of normal distribution, we have same mean, median and mode. Mean is equal median is equal mode. And you can see that it looks like a bell shape, and whenever you plot the data you can see that the left hand side and the right hand side, this means the lines or the curved line does not touch the x-axis. Okay, so you have to plot here starting from this one, and you will try to this one, and you will end at this one. So whenever you will plot the data, you will get the means diagram or the graph in such a way that the curve or the bell shaped curve, both sides of the curve does not touch the x axis, never touches the x axis. Okay, and whenever we plot the graph using normal distribution, will look like this, will look like this one. Okay, and here the curve generally starts from, the range is from minus infinity to plus infinity. Okay, we can get the values within this range. So this is called normal distribution, right? One more thing is that in case of normal distribution, you can see that if, let, this is the graph. Okay, here the mean parameter, mean means the average of the elements. Okay, the mean parameter acts as a location parameter, that means the center of distribution. It says how the graph will look like. That means if the mean is at this point, okay, the graph will look like this. If the mean is at this point, the graph will look like this. If the mean at this point, the graph will look like this. So the mean parameter acts as a location parameter, the how the graph will look like. The peak point should be pointing to the mean one or to the average value one. You can see from the graph. Okay, one another point is that if we are having the standard deviation higher, last class I have already discussed what is the standard deviation, how can you find out the standard deviation. We are using the min max location of for the pre-processing of data, right? So if the standard deviation is higher, then the curve will be wide. Okay, so let, this is the curve here, let, this is one curve and this is another curve, right? So whenever we plotted the data, we just received this kind of plots. So both these two are of bell shape, no doubt. That means the data is distributed in a proper way. But here the shape of the graph is very wide. That means if it is wide, that means the standard deviation is very high. Here the graph is narrow, that means the standard deviation is not high. Okay, so these are the things you have to remember. And another thing is that when we plot the normal distribution graph, we can have, this is the mean value. You see that this is the mean value. Okay, it is mean value is represented using mu symbol, and you can see let the values are here 50, here 60. Okay, so let the values are minus 30. Suppose I am just taking the assumption here. Here let the values are 40. Okay, so if here 50, this right hand side value will be treated as one standard deviation away from the mean value. Okay, 60 is called two standard deviation away from the mean value towards right, and minus 30 is called one standard deviation from mean towards left, and minus 40 will be called as two standard deviation from the mean towards left. So these are the parameters, these are the features that we have to just understand in case of normal distribution. Okay, so this graph also you can see, this is the wide graph, this is the graph is so narrow. that means they have the different standard deviation. This has the higher standard deviation this for this graph, because if the standard deviation will be higher, that means the values will be dispersed, then the graph will also will be wide. And if there is low standard deviation, that means the values are not so dispersed, that means you will get the narrow graph, right? So here, if they have different mean, okay, different mean, you I told that the mean parameter describes or find the location of the graph or location parameter that acts as a center of distribution, that when where the graph will be plotted, this will be treated, this can be obtained by the mean parameter. So if the mean parameter is at this point, the graph will look like this. If the mean parameter will be at this point, the graph will look like this. So the mean parameter describes or defines where the graph will be plotted. Where will be the mean value, where will be the left side value, where will be the right side value. Okay, so different mean and same standard deviation. You can see the standard deviation of these two graphs are same. That's why they are in same shape. Okay, same means the width of the graph is same because they have the same standard deviation. And why it is different mean, you can see here the mean value is here, that means the mu is here, and we are getting the plot at graph at this one, so this is the average one. Okay, so here the mu or the mean value is here, so we are getting the graph in this way, so this is the average one. So these two graphs says that different mean with same standard deviation, and these are same mean with different standard deviation. So this was all about the normal distribution. Let's check and just inform me whether all of you are clear. Let me show this again. Write in the comment box that if you are clear about the normal distribution. You can see the parameters also, or you can see the characteristics also for the normal distribution. Few features you have to just remember that if you are talking about the normal distribution, what are the kind of values we can plot, and what is the shape of the curve. Okay, it will always be bell curve. And what is the meaning of perfectly symmetrical distribution. And you can see that at the peak point or at the top or the maximum point we can have, there is the equality of mean, median, mode. And whatever the data we have, the amount of data we have, but whenever you plot in normal distribution, the curve always, that means the curve never touches the x-axis, and the range of this normal distribution always lies from minus infinity to plus infinity. And also the mean parameter, how it determines the location of the graph, and what is the effect of standard deviation upon the width of this curve, right? So these are the points you should understand about the normal distribution. Okay, so are you all clear about this? Okay, everyone, right? Okay. Main, median, mode, everyone is clear. This is the mathematical one. You must have studied in the statistics. Again, also I explained how can you find out median, how can you find out mode. Okay, right. Fine. Okay. Next is called binomial distribution, right? So binomial distribution means, as the name suggests, this is the binomial, means means two, right? Means two. So in case of normal distribution, we studied, that distribution was for the continuous value, continuous random value. So we talk about the normal distribution. So if we speak about the binomial distribution, it will be for the discrete value. Okay, discrete value means the whole number. These are not in decimal point, these are the whole numbers, right? So binomial means bi means two. Okay, that means it will talk about two values. So it is for the you can see that in case of binomial distribution, it is for the discrete value. It is used in the scenario where we have to take two values. Okay, that can be success or failure, that can be one or zero. That means when we have the two outputs, yes or no, true or false, one or zero, failure or success, so that in that case we can have the binomial distribution. That means this kind of discrete data we can take and we can plot that, then that kind of data distribution we call as the binomial distribution. Okay, so let, for example, it was discovered by James Bernoulli, and the normal distribution was discovered by the Gaussian, the English mathematician, that was James Gauss, right? So the shape of by this normal distribution was bell shape. You just remember that one. Okay. So in case of binomial distribution, we always have two values, and upon that we have to find the result. And we are just remember one thing, that we are talking about probability distribution. In each case, we have to use the assumption to get the output. We are not discussing about the means the observed frequency distribution. We are just describing about the frequency probability distribution, okay, or the theoretical data distribution, where we are using the probability value to get the data or to get the result. We have to use the assumption. So here, let we'll take the examples here. Suppose a new drug is introduced and we have to check whether the drug will be effective or not, when the drug will cure the disease or not. So here we have two cases. The drug will cure the disease or the drug will not cure the disease. Okay, so two cases we have. So we will use here binomial distribution. The data will get after the experiment or after the analysis, we will say that this is the binomial distribution of data, right? So if you take the second case, that is, suppose when you toss a coin, you will always have two outcomes, right? Head or tail. So not more than that, we do not gain anything beyond that head and tail. So always we, in that case, in that scenario, whenever we just toss a coin, we have to get head and tail. We know that we will have two outcomes. Upon the two outcomes, we have to check the probability of getting head or tail, or both head or tail, etc. Okay, so whatever the things or whatever the total outputs we will have always two outcomes, right? So in that case, we'll use the binomial distribution. And third case, that when we buy a lottery ticket, okay, always we have two probability that we can win or we can lose. So as we have two probability here, in that case we can use the binomial distribution, right? So this is called binomial distribution, and the above one was normal distribution, right? So just remember where it is used. It is used in discrete one, and where the normal distribution was used, it was used in the continuous value distribution, right? So this was all about the various kinds of distribution of data in statistics. That means you can have the observed frequency distribution, you can have the theoretical or probability distribution, or you can use the binomial distribution, or you can use the normal distribution. So generally, normal distribution is very important. You have to go deeply through it, that I explained, in order to have the better understanding upon the distribution of data, right? Okay. Let me check. Okay. Thank you so much. Okay. See, next, the important thing is central limit theory. Here I can write, where is the place? Let me check. Sim- Uh, the theory is central limit theory. Okay, central limit theory. Here I can explain. See, so what is the meaning of central limit theory here? So this is also a part of probability distribution. What is the meaning of this one? Okay, see, try to understand this one. It's very important, very easy also. Let we have this population. Okay, from the population we are extracting the sample. So this is our sample, this is our entire population, and just you studied what is the meaning of normal distribution. So in case of central limit theory, we should have knowledge about the sample, and we should have knowledge about the normal distribution of data. In both the cases we use the case of assumption, or we use probability. So let this is the entire population we have, and from that we have to extract the sample. So from the population we can have any number of samples. Okay, so as per our need we can have any number of samples from the population. So the central limit theory theorem says, or before reading this theorem we should know few things, that any number of samples you can have from the population, but we have to remember one thing, that the sample size. Okay, the sample size, what is this? This is called sample size, which we denote as in small n. The sample size should be greater or equal to 30. This is the criteria, this is the constraint. Any number of samples we can have from the population, but the sample size, or which we call as small n, that should be greater than or equal to 30. Okay, so let I extracted the sample S1 from the population P. Let it have the elements like X1, X2, and so on. Okay, let another sample I've extracted H2, and it has the elements like, let P1, P2, etc. Okay, so in this way I extracted n number of samples, and this n number of sample consists of, let x n number of element, and x n1, and so on. Okay, so these the n number of samples I've extracted from the population, and these are the elements in the corresponding samples. So what will I do? I will find the mean of the elements in each sample. So let in sample x1 the mean is sample s1, the mean of the elements are x1 bar. Suppose this is the value. Okay, then whenever I found the mean of the elements in sample 2, let I got the mean as x2 bar. Okay, and likewise whenever I received, or I find out, or I calculated the mean of the elements in Sn sample, let the mean I received, it is xn bar. So in each sample I just find out, or I just calculated the mean of the samples. Okay, so mean of the samples means mean of the element that is present in the corresponding samples. So here we received the samples as x1 bar, x2 bar, likewise xn bar. So whenever after getting the mean of the samples, I have to plot the mean. So whenever I plot the value of the mean as I received, then you will surprised to know that it will give the shape of a bell. Okay, it will give the shape of bell. That means there is the normal distribution of the probability of the data that we received. Okay, so the central limit theorem says that whenever you collect the data that may be of any sample, may be of any number of sample, and the sample size is, if you are getting the sample size that is greater than or equal to 30, then whenever you will plot the values, or plot the means after being calculated from the each of the element that is present in the sample, you will, it will give you a bell shaped curve. Okay, that means that will be the normal distribution of the mean of the samples. So this is called central limit theorem, that is CLT. Okay, so am I clear about the central limit theorem? Anyone, please write in the comment box that you are clear about the central limit theorem. Am I clear? Explain again. Okay, okay, sure. Okay, see, central limit theorem is one, it is based upon the probability distribution, right? The first thing is that it is based upon the probability theorem. It says that suppose you have a population, as I explained here, that you have a population. Okay, this is the population you have. And as we know that if you have a population, we have a larger data set, then we can have any number of samples from the population. Okay, because for sample we select from the population. So as we are given number of data set, that means huge population is there, we can extract any number of samples. And whenever we extract sample, if we just kept our sample size, that is n, that means the number of elements in our sample should be greater or equal to 30. This is the criteria, this is the constraint that should be with the sample size in order to satisfy the central limit theorem. Okay, so if we say that whatever be the number of samples we are collecting from the population, if we plot these the samples in a graph, if you think that it will be in normal distribution or it will be in the shape of a bell curve, that means you have to satisfy the central limit theorem criteria. That means whenever you are selecting number of samples from the population, make sure that the sample size should be greater than or equal to 30. Okay, so let you selected sample 1 from this population and you kept the elements, and make sure that you are taking the elements equal or greater than 30, right? When you are just you collected sample 2 and you consider the elements and you make sure that you are taking the sample size greater than or equal to 30. So likewise you can collect number of samples from the population, and in each population, in each sample you are containing or you are just putting or you are just selecting the number of element that is greater than or equal to 30. So then as per the central limit theorem, what will we do? What will to be done? That you have to find out the mean of the elements that are present in each sample. So as we have n number of samples collected from this entire population, so I have to find out the mean of these elements. So suppose I have taken 30 elements here, then I have to add all the elements and divided by 30. In this way I will find out the mean of the elements present in sample 1. Same here, if suppose I have considered here 40 elements, because the sample size would be greater or equal to 30. So let in second sample I have put 40 elements. Then what will be the mean? How can I find out? I have to add all the elements divided by 40. So I will get the mean of sample 2. So likewise, I have to find out the average or mean of the elements present in each sample. So after getting the mean, so let the mean of the first element, I am denoting it as x1 bar, and the mean of the second sample, I am denoting it as x2 bar, and likewise the mean of the nth sample, I am denoting it as xn bar. So whenever after getting the mean of all the samples or mean of the elements present in each of the sample, whenever you plot the mean, okay, whenever you plot the mean, you will see that the mean data are forming the shape of a bell curve. Okay, that means the data or the main data are normally distributed. So central limit theorem says that when you collect data that may be in normal form or not, if you will take the sample size greater than or equal to 30, then you have to calculate mean and plot it. You will always get the bell shaped curve. So this is called the central limit theorem. Yes, bell curve you will receive. Okay, so whatever the data you will take, that when that means whenever you will select the data that may be in normal distribution form or maybe in not in normal distribution form, but whenever we will take the samples with size greater than or equal to 30, okay, then calculate the mean and plot it, then it will give you a bell shaped curve. So this I want to say you that this is the main theme of central limit theorem. Okay. So clear about this? Okay. Yes. Okay. See, you can draw any number of samples that I told. Any number of samples you can have. So you will get or you will plot the data as per the mean value considered from those only. Okay. So if you are considering only 10 samples, then you will get 10 values, or 10 mean value. Then considering these 10 values, you have to plot. Then whenever you will plot, you will at that point also get the curve that you will be in bell shape. Fine. Okay. Any number. That's why I repeatedly told that whenever you will extract samples from the population, you can have any number of populations. So that depends upon you. That according to which how many means a number of means you have to plot the data. So as you will get much more data, you will also get the bell shape. If you will take less data, according to that you will find the mean value. You will also get the bell shaped curve. So no issue. That it depends upon the on you that how do you like, you want to take much more data or less data, but in both the cases it will give you the bell shaped curve. Yeah, same, okay, okay. No, you will not be given to plot the data, right? So you may ask that the difference, just explain the central limit theorem. At that point, you will just have to write that this is the basic mechanism through which we can explain the basic central limit theorem. Okay. So you will just have to explain using the examples that these are the samples. If you will take that, you will get the data in bell shape. So when you will plot in your answer sheet, you have to just see that if you want to give the example, you can take the original value also. Okay, you take some values in the entire data set, and from the data set, you just draw the samples, making it sure that the sample size should be greater or equal to 30. You can take 30, you can take 40, you can take 32, you can take 33 number of elements and find the mean value, and you just don't have to plot originally. You just draw a graph and just show the examiner that whenever you will plot, it will look like a bell shape. But originally, if you are given with the means the chart sheet, whenever you will plot that data, you will at that time you will definitely get the bell-shaped data. If the chart sheet is not provided to you, then you have to just show the graph in your answer sheet to just explain that it will look like a bell shape. Okay, okay. So whenever we'll yes, yes, lab class. Lab class I will conduct, and at that time we'll explain everything. Okay, so this is the what this is the what you can see the theoretical portion. So we just have to understand that this actually happens. Okay, so as I told you, the hypothesis case, we have to use the MATLAB, we have to use the confusion matrix. So here we are just knowing the means getting the knowledge that this is the way by which we can implement. And in practical, whenever we'll just conduct the practical classes, at that time I will show you how can you plot, how can we get the actual data if you have this kind of inputs, right? Sure, everyone clear about the concept? Am I clear to everyone?
Yes, ma.
Okay, see, next we start. Okay, next is called Bayes theorem. Okay, so Bayes theorem is upon, it is also based upon the conditional probability, right? Conditional probability. We have already thought about the conditional probability. That means it will be like this: probability of A upon B. That means if A and B are two dependent events and B has already occurred, then what is the chance of A will occur? Okay, this is called conditional probability. So Bayes theorem is also based upon the conditional probability. Here we have two events A and B, right? So A and B are dependent events, and the total space which has occurred, that is B has occurred, and we can, what is the probability of getting A from B? It will be A intersection B, right? Then if I say what is the probability of getting B if A has occurred, what you can see, what we can say that A has already occurred. Okay, A has already occurred, so total we have received A. Then the probability of getting B out of A, we can say it is B intersection A. So these are the things. Okay. So you can see that if I can write in this way, can I write in this way that P probability of A bar B. Here the straight line says given that. What is the meaning of this straight line? This straight line is the given that. That means key probability of getting A given that B is true or B has already occurred. B has true or B has already occurred. It is given, and what is the probability of getting A? Okay, so this straight line or straight bar says given that. So when whether I can write here P a probability of A upon B dot. Here I can write in this way: probability of A, just check and say whether I'm correct, dot probability of B. Can I write in this way? I'll just multiply this and this. Okay, this is correct. Is equal probability of A intersection B. Okay, I will just multiply this and this, then it will be equal to probability of A intersection B. Then when I will multiply these two, probability of B upon A dot probability of A, that will be equal to probability of B dot A, B intersection A. So it will be written in this way: B upon A, I multiply that with the denominator, that is probability of occurrence of A, then that will be equal to probability of getting B intersection A. Okay, same thing I did in the first means equation, that probability of getting A upon B dot probability of B is equal to probability of getting A intersection B. So you can see that right hand side, the RHS is same. Probability of A intersection B is equal to probability of B intersection A. Both are similar things. So as the right hand side or RHS is same, we can just equate the LHS also. That means the left hand side will be same. So we can write here that probability of A, just check out, A intersection B is equal probability of A upon B dot probability of B, and it is equal to probability of B prob that means just I equated the right and left hand side because right hand side is same. So I can write probability of A intersection B or probability of B intersection. This is the same case. So it will be equal to probability of A upon B dot probability of B. That means the first LHS of the first equation and this is the LHS of the second equation. Okay. So as the RHS is same, so LHS is also same. So from this above equation, this equation, can I write here? Can I write the probability of A bar or A upon B is equal to probability of B upon A dot probability of A and divided by probability of B. Can I write in this way? Is it possible? Just you have to write the probability of A upon B is equal this much divided by probability of B, because this is multiplied here. So when it will come to the denominator, it will be divided. Okay. So you can write in this way, probability of A upon B is equal probability of B upon A dot P probability of A divided by probability of B. So this is what the first thing. This probability is called posterior. Okay, posterior. And this probability is called the likelihood. You can see the likelihood. And this probability is called prior. You can see here prior. And the last one is called marginal. Okay, marginal. That means using probability, how we can find that if something is given, how we can find another value using Bayes theorem. So Bayes theorem uses the probability. So you have to just to find out that how the equation looks like. So how will be the equation will be, I just explained that how we can find this equation. So actually this is the equation for Bayes theorem. So directly it is written. Okay, so I took A and B. Here it is written H and D. So D stands for data and H stands for the hypothesis. Here A is hypothesis, B is the data. Same thing is written, but it is directly written. I just told you how can we get the equation, the same equation, how can we get. So here A stands for hypothesis here and B is the data. So whenever you see this one, this posterior says what? If data if data is given, what is the probability of getting the hypothesis will be true? Okay, this is the posterior one. We want to find the hypothesis that we have assumed, how it can be true or whether it will be true if we have given the data. And this marginal or the pure evidence, this is called pure evidence. That means the data is actually given. So marginal says what is the probability of collecting data under all the hypotheses. That means we have to collect the data. What is the probability of getting the data? So this is the marginal value or the pure evidence, right? So this is what this is called, this probability is called prior or pure hypothesis. This says the probability of the hypothesis is true before collecting the data. That means whenever we collect data, we always ensure that whatever the assumption we are having, that will be true, or the chances of getting the data will be true. Will definitely will get the data. So the probability of getting the hypothesis true before collecting the data. That means whenever we try to collect the data, before collecting data, we just assume that we will get the data. So the probability of hypothesis of getting the data will be true. So this is called prior. Then next, this probability is called likelihood. So likelihood tells that the probability of getting data when our hypothesis is true, when our assumption is true. Hypothesis means assumption. So when our assumption is true, what is the probability of getting data? That we have assumed that it is the process, or these are the techniques through which we can access the data. So if we are very much sure that our hypothesis or our assumption is true, then what is the probability of getting the data? So you can write in this way. So this is the actual equation using which we can have, or we can get using the Bayes theorem. So two questions generally comes upon the Bayes theorem. One is you have to explain the Bayes theorem, how it looks like, or what is the meaning of this one. Just you have to explain the equation, all these things. And another thing, that you can get a numerical question on the Bayes theorem. The two types of question generally comes for the Bayes theorem. So theoretical person, I just explained that what is the meaning of Bayes theorem, what are the various components in the Bayes theorem equation, and how can you get the Bayes theorem equation done. This is the theoretical portion, right? So you can also get a question. So now we will discuss one numerical question upon the Bayes theorem, right? So are you all clear about the theoretical portion of Bayes theorem? Theoretical portion means you have to just understand what is the Bayes theorem uses what, and how we can find the equations, and what are the various you can say the postulates or the features in a Bayes theorem equation. It is not much more difficult, but you have to just understand how we can deduce the theorem or equation in the Bayes theorem, and how we can solve a problem. So generally question asks on the numerical value to find out the result using the Bayes theorem. So nothing has to worry, everything will be given. Just you have to put the equation and you have to find out the result. Okay, so you need the practice. So let's work out a numerical problem upon the Bayes theorem. So shall I? Okay. Any doubt regarding the Bayes theorem? Anything you want to ask? Or am I clear to everyone?
Yes, Ma, you are
Just check
clear.
out.
You can continue.
Okay. See. Next, just see one numerical question. Better it will be good if you write the question in your notebook, so that if you, whenever I will just work out here, it will be easy for you to understand, right? See, suppose a question is, okay, let's see. Mm, okay, the question is that what is the probability of, let it is written in this way, probability of getting king. Okay, king upon face. You must be playing the card. So it is, the question is based upon that. So you know that there are 52 cards in a deck. Okay, so if you have played, you must be knowing that there are 52 cards in a deck. So we have to apply Bayes theorem to get our answers done. So let the question is, find or the probability of getting my card as king, given that it is a face card. Okay, That means ki I have given a face card, but I have to check whether the face card given to me is king. Okay, this is my question. You have to find out the card which is king when you are given with the face card. That means you are given a face card. You have to check whether that face card is king or not using Bayes theorem. So what is the probability of getting the face card as king? So you have to find out that probability using Bayes theorem, because you know Bayes theorem uses probability. So whatever the answer we will have, that will be in the form of probability. So that can be in the form of fraction, that can be in the form of percentage, or can be in the form of decimal. So it depends upon you that how you want to interpret the result, but definitely that will be in the probability form, because here the cards you have given, the face cards you have given, and the probability of getting the face card as a king, that you have to find out using Bayes theorem, right? So directly in the exam, what you have to do, nothing have to worry, everything will be given. You have to just find out which one will be what. So just apply the Bayes theorem, the things we have studied here, the application, this equation 1, then try to find out the value. So what we'll do, that we know that when we'll apply, let I have to find out the equation. I will apply in this way. The probability of face, let's write the equation. You also write in your copy, face upon king dot, just see the equation here and just see what I am writing here. Then probability of getting king, okay, then divided by probability of getting face. Okay, so here what is your data given? Your data is face, right? What is your probability? What you want to find out? You want to find out the probability of getting king. So here you can see what is given, data is given. What you want to find out? The H1. Okay, so here you can see what is given, B is given. What you want to find out? A. Okay, so same thing I have used here. This is given face, that means your card or face card is given to you, and you have to find whether that is king or not. So what is your hypothesis or what is your assumption? You have to find king. So this is the hypothesis here. This is the hypothesis or this is the assumption. This is the value of A, and B is given. The data is given. What is the data? Face card is already given to you, right? So when you will just divide, or you just find out the further simplification of this one, you can get probability of data upon hypothesis. So what is data here? Data is the face. How data is the face here? Because you have given a card, that is the face card. So what is given to you? Data is given to you. So what is the data? The face card. What you need? What is the assumption? What you need, actually you need to know that whether it will be a king. So you have to write in this way. And what is your assumption, what is your prior, that if before collecting the data I have to assume that my hypothesis is true, that means before collecting all the face cards, that I have to assume that any king that I will choose from the deck, that will be a face card. Okay, so I can write here probability of king, then divided by probability of data. That means you can see that this is the probability of collecting data under all the hypotheses. So it says how many total number of face cards are there among the 52. So this is the entire equation that I set as per the Bayes theorem. Okay, so whenever I just find out the equation, here you can plot the value, you can find out the value. You see here we told that we have given the face cards we have given, and our hypothesis is to get the king card. That means the probability that I have given a card, and the probability that that card is face card, it is 1, right? It is 1. Whenever I have given the cards, the probability of getting the face card, or I have to think that card is the face card, is 1. Okay, that means it's always a face card. That's why I am writing as 1. Then dot. Here, probability of getting king card, right? Probability of getting king card. So total number of cards we have, how much? It is 52 in the deck. And how many number of king cards are there in the deck? You know there are 4 king cards. So the probability of getting king cards out of all the cards in the deck, that is 4 by 15. Then divided by probability of getting face cards. So how many face cards are there? We have total 52 number of cards in the deck. And how many face cards are there? In case of queen, you have 4 face cards. You have, in case of king, you have 4 face cards. And in jack, you have 4 face cards. So total you have 12 number of face cards. You must have seen in the deck while you are playing the cards. Okay, so this is the equation. So when you will solve, you will get 1 by 3. Okay, so there is the this much probability of getting the king if you have given the face cards, right? So in this way you can solve the Bayes theorem. Yeah, this was very easy. So this kind of numerical values, numerical questions, you will be obtained in your exam. And if it is given, you have to just put the equations and find out the result. Okay. So you can also change this to the fraction, to the percentage value. Okay. So divide by 3 and multiply with the 100. Okay. So clear everyone? Okay.
Yes.
Okay. Thank you. Thank you so much. Next, C. Today I will take half an hour more so that I can just cover up all the topics, right? So it is the last class of theory. So don't be panics. I will just extend half an hour only, not much more than that. Just have patience so that we can cover up. See, next. Okay, so the next important topic is called hypothesis, right? So we covered this distribution, the probability distribution part, and now we have hypothesis, right? So what is the meaning of hypothesis? So when we are discussing about the Bayes theorem, we frequently have the term hypothesis. Okay, and at that time I told you that hypothesis is nothing but the assumption, right? So hypothesis is what? Hypothesis is simply, it is a guess, or you can say it is an assumption. Okay. So first of all, what we need, that whenever we analyze your data, what is the need of analysis of data? Because we want to clarify the problem we have. We have some problem, we have to gather answer regarding that problem, we want to solve that problem. So that's why we are analyzing that. Okay. So first of all, I have to identify a problem, right? This is the problem I have to identify the problem, that what we can do to solve my problem. So the analysis of data analysis starts with the identification of problem. Then according to that problem, suppose I have some problem and I just analyze what can be the solutions, or what things are done to solve the problem previously. So what are the things? Then that means I am just gathering the knowledge regarding the problem. If there is anything that is previously done to solve the problem, so that things I am covering, or I am just extracting from any other sources. So that is the knowledge I am gathering. So after gathering knowledge about my problem, I just made a guess. I just made a guess. So what is this? I thought that this will be the solution of the problem that is identified me. That means the guess about the solution of the problem is called hypothesis. So we cannot say that what is the guess or what assumptions we made or what hypothesis we made that is perfectly true. It may happen that whenever we test the assumption, we can get the positive value, or whenever we test the assumption, we can get the negative value. So we cannot say that the assumption we made about the solution of the problem is perfectly true. So the hypothesis is a tentative solution. It is not a permanent solution because we are assuming, we are not sure that this is the solution. We have to prove that. Okay, so in order to get the that hypothesis true, we have to prove that, right? So as we have not proved the hypothesis, we are just assuming. Okay, we are just assuming that this will be the solution. So hypothesis is called a tentative solution. Of course, it gives a solution, but it is tentative. So it is not permanent. In order to make it permanent, we have to test our hypothesis. We have to prove our hypothesis. We have to prove that what the things we have thought, what the applications we have thought, those are actually mandatory to solve the problem. So we have to prove that. So as we have not proved our assumptions, or our assumption is called tentative or not permanent, right? So let's consider an example. Let my study is on the obesity, right? Obesity. So I studied the data about the cause of obesity, and I thought that obesity can be reduced through walking. So if people will walk, they can get rid of the obesity. Okay. So if we walk 10,000 steps per day, obesity can be reduced. This I thought. Okay, this is my thought, this is my assumption. I thought if people will walk 10,000 steps per day, then obesity can be reduced. This is my assumption only. This may be true, this may be false. So I will collect data upon this and will test to know that whether my hypothesis, whether my assumption that if people walk 10,000 steps in a day, the hypothesis will be the obesity will be reduced or not. So hypothesis is to be tested to check whether it is true or false, right? So here hypothesis, you can say this is the presumptive statement or a reasonable guess, because it is based upon the available evidence. Whenever we want to make a guess, we have to collect data regarding our problem. So basing upon the data we have collected, we have to make the assumption. So always the assumption or the hypothesis is based upon certain evidence, certain data collected. So that's why it is called a an educated guess or the presumptive statement or a reasonable guess, right? So when the data analyst gets the hypothesis always need to be tested to make sure that the assumption that we have to solve a problem is true or false. So this is called assumption or hypothesis. So am I clear about the hypothesis? What is the meaning of hypothesis here?
Yes, ma, very clear. It is understandable.
Okay. Yeah. See. Next, discuss some few characteristics of hypothesis, right? So I told that hypothesis is testable. That means when we make some assumption, we have to prove our assumption. I told this is the technique that by which you can solve the problem. I have to show you that this is actually the technique through which we can solve the problem. That means my assumption should be tested. So the first characteristics of hypothesis is the it is testable. Then second one is specific. That means the hypothesis or the assumption you are making, that should be specific to the target, that should be specific to the problem. That means the problem you need to solve, you have to collect the data, and basing upon the data you have to generate hypothesis that is specific to solve that particular problem, that should be related to solve that particular problem. So your hypothesis you are generating, that should be specific or to the point, to the for the problem you have to solve, right? The third one is called, third characteristics is called hypothesis is logical. That means the hypothesis should be according to the problem. It should have the reasonable reason that why we have developed the hypothesis, because we have developed the hypothesis to solve a problem. So this should have the particular, it should have a proper reason of development, that why we have developed the hypothesis, because we have to solve this problem. And the hypothesis that we have developed, that is that should be, that must be related to that problem, right? Next, the hypothesis is predictive, because you know that using hypothesis, it is the assumption, you are assuming that this is the way through which I can solve my problem. That means you are predicting the answer. That may be, that may not be the permanent answer, but you are predicting the answer, you are predicting the solution, that this is the way by which I can solve my problem. So the hypothesis is predictive. And the hypothesis is concise also. Concise means the hypothesis should be short and clear to the point, or clear to the problem solving capability. And the hypothesis should be relevant one. That means it should be related to the problem that I want to solve. It should be very relatable to for the problem for which I have to develop the hypothesis. And last one, the hypothesis is empirical. Empirical means the scientific one. Why it is called empirical? Because the hypothesis that we generated, okay, or the hypothesis that we have developed, we have to prove throughout our analysis of data or data analysis process. I have to prove my hypothesis, because at the very beginning I just described that this is my problem, I collected my data, then I made the assumption, made the hypothesis, then I have to prove, yes, these are the techniques, these are the procedure through which I can actually solve my problem. So these hypotheses that I developed at the beginning of my analysis, I have to prove throughout my data analysis, to check, to say that whatever the solution I have, that is true or false. So this is, that's why the hypothesis is called empirical one. It is the scientific one, that it is to be proved. So empirical here in this sense means the hypothesis is to be proved. Next, there are two parts of hypothesis, right? First one is hypothesis generation, second one is confirmation. Okay, so what is the meaning of hypothesis generation? It is the hypothesis development. Whenever you are finding a problem, you are collecting knowledge about that, then you are developing or generating a hypothesis. You are thinking that if I will apply method X, then my problem will be solved. This is your hypothesis you have developed, you have generated. This is called hypothesis generation. And what is this hypothesis confirmation? That means you are confirming that what you have assumed, what the solution you have, what is your hypothesis, that is correct, that is true. That means ki the hypothesis you have generated, you have now tested your hypothesis, and you can now confirm the assumption I had at the beginning of data analysis, that is true, or that is, or you got the result that is false. So whatever the hypothesis confirmation you have to prove, that is called hypothesis confirmation. Generally it is the hypothesis testing, to check whether your hypothesis or assumption or the guess is true or false. Okay, this is two parts. Next, see, generally we have two types of hypothesis, right? The assumption we have generally two broad categories it has. First one is called null hypothesis. It is denoted by H naught. And the second one is called alternate hypothesis, denoted by H1 or HA. A stands for alternate, right? So these are the two types of hypothesis. Here, what is the meaning of a null hypothesis? Null hypothesis says that if there is independent variable, if there is dependent variable, that there is no effect, no relation between the independent and the dependent variable. There is no relationship between independent and the dependent variable, or the independent variable does not affect does not affect the dependent variable. So what is the meaning of independent dependent variable? I explained yesterday very with the example also. I hope you all have understood the meaning of independent and dependent variable. Okay. So in case of null hypothesis, it says that independent variable does not affect the dependent variable, and there is no effect, no difference, no relation between the independent variable and the dependent variable. Alternate hypothesis is the opposite one to null hypothesis. It says that independent variable affects the dependent variable, right? There is relationship between the independent and dependent variable. This is called alternate hypothesis. Okay. For example, you can see that let the previous example I am taking, let my hypothesis is if we walk 10,000 steps in a day, obesity can be controlled. This is my assumption, right? So if I will apply null hypothesis, null means nothing. You can remember from this one, null means nothing. That means no change, no difference, no relation. Alternate means yes, something is there. Okay, that means there is a relationship between independent and dependent variable. So if I consider null hypothesis, my assumption is if we walk 10,000 steps in a day, obesity can be controlled. So null hypothesis will say no, it won't happen. Okay. Though we walk 10,000 steps, we cannot reduce obesity. That means there is no relation between obesity and the steps of walk. Right? So this is null hypothesis. Alternate hypothesis will say yes, if we walk 10,000 steps in a day, obesity will be reduced. Right? This is the alternate hypothesis. So whenever we get any null hypothesis, we have to report that. If you get the alternate hypothesis, we also have to report that, because in our data analysis, if we succeed, we get knowledge. If we fail, we also get knowledge. So whenever we test our hypothesis, that can be null hypothesis, that can be alternate hypothesis, we both have to report. If we are succeeding, we have to say that yes, my assumption is true. If we are getting failure, then we have to say no, my assumption is not true. Okay. So this is the case. These are few questions. Just read out the questions and just try to answer. Just I am explaining the other things, and till that you just try to answer what will be the answer of these questions in the chat box. Okay. So first question is the statement made about the population for testing purpose. If there is a population, we are making a statement from the population and it is to be tested, then what the statement will be called? The first question. Okay. See, then hypothesis is a tentative solution, true or false? Why? If it is a tentative solution, why? If it is not a tentative solution, then also you have to mention why. And I told you that whether hypothesis is a tentative solution or not, and why it is a tentative solution not, I also explained. So try to answer. Okay, see. Next is called, yeah, yes, sure. Okay, welcome. See. Next is called error. See, the most important question in hypothesis generally question is asked upon type 1 error and type 2 error. So what is the meaning of error here? Error means something that is not expected, right? So we are expecting something, but we received something. That means there is no matching of the expected value and the received value, that we call as error. So we can have any kind of error. We can have measurement error. We can have error during calculation. We can have human error also. Randomly when we are collecting data, we at that time can also have error. We can also have error during collecting a process or conducting a process also. So many types of errors are there. But in case of probability, we have two types of error, that is type 1 error and type 2 error. These two types of error are very important. Okay. So before knowing that, you should know null and alternate hypothesis. I just explained this one, null hypothesis and alternate hypothesis, right? So two cases. See, if you are getting null hypothesis, like it is H naught, and alternate hypothesis, that is H1 or HA, right? Alternate hypothesis, otherwise called as research hypothesis also. Remember that one. So null hypothesis and alternate hypothesis. See, if null hypothesis is rejected, listen carefully. If null hypothesis is rejected, that means we have to accept this alternate hypothesis, right? There are two statements. If someone rejects null hypothesis, then alternate hypothesis will be accepted. Are you getting my points? Null hypothesis is rejected. So null hypothesis says there is no relation. If we are rejecting that, that means we are agreed upon that there is relation. If there is a relation, that is a part of which kind of hypothesis? That is the part of alternate hypothesis. So it is written, if null hypothesis is rejected, then alternate hypothesis is accepted. If H0 will be rejected, then we have to accept H1. Okay. And the opposite one, suppose null hypothesis is accepted. Okay, so null hypothesis accepted means null hypothesis says there is no relation. If you are accepting that, that means you are saying that whatever the things in alternate hypothesis says there is a relation. That means you are rejecting that one because you are accepting null hypothesis. So when you will accept a null hypothesis, you have to reject alternate hypothesis. This is the rejection of null hypothesis. This is called the acceptance of null hypothesis. Right? Are you getting my points? If null hypothesis will be rejected, alternate hypothesis will be accepted. If null hypothesis will be accepted, alternate hypothesis will be rejected. This is the most important point. Okay, up to this
Okay,
clear?
excuse me,
Any
ma'am.
doubt? Any
Yes, ma'am.
doubt?
Yes. I
Yes.
have a question, please. Is this
Yes.
type one error?
No, no, this is not type 1 error. I have
Okay,
not
so
yet explained type
is
1
it in
error.
general? So in general,
Yes, it is general.
once
Okay.
um, once the null hypothesis is accepted, automatically the alternative hypothesis is going to be rejected. Or if
Yes, yes.
alternative is accepted, the null is rejected automatically for all the
Yes,
errors.
yes, yes. Okay. Just wait. I am just saying about the error. I have not yet gone to the error portion. I am just explaining in details because type 1 error is related to these points. Okay.
Okay, okay, ma'am, I understand.
Yeah. See, I was just saying that this is the case that you understood. Okay. See, that is suppose H0 or H naught, that is the null hypothesis, is rejected by mistake. Are you getting my point? Null hypothesis is rejected by mistake. It is called type 1 error. Okay. If H0 is rejected by mistake, we do not want to reject the null hypothesis because null hypothesis is true. But by mistake, during our experimentation, we rejected the null hypothesis. We can say there is an error occurs because we are very sure that null hypothesis is true. We do not want to reject that, but by mistake we rejected. That means there is the deviation of our actual value and the expected value. So this is a kind of error. This is which kind of error? This is called type 1 error. So type 1 error occurs when H naught or null hypothesis is rejected by mistake. In simple. Okay. Then what is type 2 error? If H naught or null hypothesis is accepted by mistake. Okay, that is called type 2 error. H naught is accepted by mistake. It means H naught is to be rejected. Okay, we need to reject H naught, but it is accepted by mistake. We say this is type 2 error. Okay, so 2 points are there. If null hypothesis is rejected by mistake, that means we say that type 1 error. And if null hypothesis is accepted by mistake, that is called type 2 error. So two kinds of errors are there in case of hypothesis. Okay, so let's take the example of type 1 and type 2 error. So let's the example of medical testing is there. Suppose a medical test is designed to diagnose the disease, right? So null hypothesis will say it will always deny the things. So null hypothesis will say that the person does not have disease. This is the null hypothesis because null hypothesis say there is no relation. Okay, if person is a variable and disease is another variable, there is no relation. Okay, so that's why we are writing a person does not have disease. This is the part of null hypothesis. Then the opposite, the alternate hypothesis will say, it will say the person have disease. Okay, this is two parts. Then type 1 error will occur when? Type 1 error says that H0 is rejected by mistake. H0 or H0 is rejected. That means here, if H0 is rejected, what is written here? The person does not have disease. Okay, the person does not have disease. We rejected that one. Rejected means we told that person has disease. Okay, if we are rejecting H naught, H naught is written here, person does not have disease. We rejected that one by mistake. Okay, this is true, but we rejected by mistake. So if we are rejecting this null hypothesis, what we are saying, the person has disease. This is the error because we know that person does not have disease. We have to accept the null hypothesis, but by mistake we rejected the null hypothesis because of error. So what kind of error that is? That is called type 1 error. So type 1 error will see that the person has disease. We rejected null hypothesis by mistake. Okay. Next, type 2 error says that H naught or null hypothesis is accepted by mistake. Okay, accepted by mistake. Same example you will take if you are saying about the medical testing. Suppose null hypothesis is accepted by mistake. A null hypothesis say a person does not have disease. This is accepted by mistake. That means the actual should be the person have disease. This is the actual one. So when we say the null hypothesis is accepted, that means we told that yes, the person does not have disease, and this null hypothesis is accepted by mistake. So when we are accepting the null hypothesis, that means we are rejecting what? We are rejecting the alternate hypothesis. That means the actual result should be the person has disease, but we accepted the null hypothesis by mistake. That means we are saying that the person does not have disease. So this is called type 2 error. This is the type 2 error, right? So clear about type 1 and type 2 error. Let's check the things that what I told you.
Ma, this type 2 error is so difficult. I didn't get it.
See, type 2 error means what? Are you clear about null hypothesis?
Yes, ma.
Are you
Yes,
clear
ma'am.
about null hypothesis?
Yes,
Okay,
yes.
null hypothesis. See, so try to understand. Null hypothesis says there is no relation. Okay, if I'm saying person and disease doesn't have any relation. This the null hypothesis says. Alternate hypothesis says the person and disease have relationship. That means the person has the disease. As we can see here, null hypothesis and the alternate hypothesis, right? So if we have the type 1 error, try to understand. If we have the type 1 error, type 1 will say, write in your copy, that type 1 error will say that null hypothesis is rejected by mistake. Okay, if something is rejected by mistake, that means that is true. That is true, but we rejected by mistake. Okay, when H naught or null hypothesis is rejected by mistake, that means null hypothesis is true. That is our result, but we reject null hypothesis by mistake. Okay, here you can see null hypothesis says what? Person does not have disease. This is the null hypothesis. We reject this null hypothesis by mistake. That means we said if we are rejecting this, then what we will say? That person have disease. We say that person have disease. This is after rejection of the null hypothesis. So if we are rejecting the null hypothesis by mistake, then that will be called as type 1 error. So type 2 error will be what? That if the null hypothesis is accepted by mistake. Null hypothesis, we shouldn't have to accept the null hypothesis in our experimentation, but we accept that by mistake. We do not know that we do not want the null hypothesis in our experiment, but we accept the null hypothesis by mistake. This is our mistake, that we say that yes, there will be null hypothesis in my data analysis. So what is the null hypothesis here? That is saying that person does not have disease. The null hypothesis say that whenever I am conducting an experimentation, when I am conducting an data analysis, the person does not have any disease. This is my assumption after the study. I am saying no, you do not have any disease. This is my null hypothesis. Okay. And if the null hypothesis is accepted by mistake, I know that person has disease, but whenever I collected data, because of some partiality, because of some biasness, there occurs the result or the assumption that that person does not have disease. But I know the person has disease. So which one I have to select? The person has disease. But here what is the person does not have disease. This is the null hypothesis. This is accepted by mistake. That means I told that yes, the person does not have disease. But I have to say no, uh, the person has disease, but I told that the person does not have disease. So here the null hypothesis is accepted. This line is accepted by mistake. I have to include that the person does not have disease, but I know the person has disease. So I have to include the alternate hypothesis, but by mistake I include the null hypothesis. That means the null hypothesis is accepted by mistake. By mistake I told the person does not have disease. So this is the mistake occurred by me. So this kind of error is called type 2 error. Okay. Am I clear? You write, everyone, you write one thing.
Yes.
Everyone, you write one thing in a copy if you have copy and pen. Write that if, I'm just dictating, you write if H naught or a null hypothesis, if null hypothesis is rejected by mistake, if null hypothesis is rejected by mistake, this is called type 1 error. This is called type 1 error. Okay. Just remember two lines that I am saying, you will be very clear. Okay. If null hypothesis is rejected by mistake, this is called type 1 error. Second point, if null hypothesis or H naught, if null hypothesis or H naught is accepted by mistake, is accepted by mistake, this is called type 2 error. Simple. Two lines you have to understand, you have to just memorize that this is the case where type 1 error will occur. This is the case where type 2 error will be occur. So you will be very clear. So do not go through any other things. This is the main the gist that is that generally asked in the question. What is type 1, type 2 error? Just explain. This is the type 1 error. This is the type 2 error. Before that, you have to explain what is null hypothesis, what is alternate hypothesis, and give one example of type 1 and type 2 error that I showed you. It will be very clear. Okay, welcome. Next you see, okay, next the things are hypothesis testing. Very important topic this is hypothesis testing. See, question generally asked upon the hypothesis testing, what you can see here. Just I'm just explaining and try to understand. If you will get difficulty at any point, then you can ask at immediately also. Okay. Hypothesis testing. Here I have to test my hypothesis. That's why I told the hypothesis is a presumptive statement. It is an tentative solution because we have to test the hypothesis or the assumption we have, right? So in this case, we always select the sample and do analysis on the sample, because whenever we'll do analysis of the sample, we can apply that to our whole population, to in order to ensure that whatever we are applying on my sample or whatever we want to apply in my population, that is as per the requirement. So I have to test my hypothesis. So whenever I will test my hypothesis, I will always start with a problem as I discussed. So till we got the problem, what are the previous analysis are done against the problem is needed to be collected, so that we can have a prior knowledge about the problem and we can proceed according to that. So in entire data analysis, in our entire data analysis, starting from the beginning to the end, we have to test our hypothesis, we have to test our assumption to make sure whether it is true or false, right? So the types of hypothesis testing is of two types generally, that is one-tailed test and two-tailed test. Again, this one-tailed test is further divided into left-tailed and right-tailed. Here, what you can see, that you know that when you are saying about the alternate hypothesis, it says there is a relation. That means it has more value, it has less value, or it doesn't have equal value. But when we have null hypothesis, we say there is no difference, there is no relation, there is no impact. This you have clear. Then, if we have the assumption and we have to find the maximum value, this question, maximum value, the sample has more value than that one, then we have to apply, sorry, the less value, we have to apply the left tailed test. And if we have to apply the maximum value, or we have to test the maximum value of occurrence of my assumption, or whether my assumption is more valuable than other one, I have to find the right tailed test. If I have to check not equal one, then I have to go with the two tailed test, right? So these are the three things that you have to understand. Less one, left tailed, greater one, right tailed, not equal, two tailed test. So what will be? How can we check? See, suppose we have, see, if the alternate hypothesis says this is greater, okay, this is greater, then we have to check right tail test that I explained right now. Then if my this alternate hypothesis says this is smaller, we have to test with left tailed test. And if the alternate hypothesis says this is not equal, that means we have to test with the two tailed test. And one thing you remember, always we have to test the null hypothesis, because null hypothesis says there is no relation. So in our entire study, we have to test the null hypothesis. So let we have to check about two-tailed test here. So two-tailed test means, suppose the alternate hypothesis say, try to understand, it is very important. So suppose the alternate hypothesis says that girls or boys are not equal in performance. This is what? This is not equal. Girls and boys are not equal in performance. So it says, it implies that maybe girls are more in performance or girls are less in performance. There may be two cases, na? Girls and boys are not equal in performance. That means either girls are better or boys are better. So girls are more in performance or girls are not are less in performance. So as it may come in two parts, so we use two-tailed test here. Okay. So two-tailed test says that in case of our alternate hypothesis, girls and boys are not equal in performance. Our alternate hypothesis says, because alternate hypothesis says that there is relationship between the variables. Okay. So When we say about our alternate hypothesis, this says that girls and boys are not equal in performance. So if this is told by the alternate hypothesis, then what about null hypothesis? Null hypothesis will be opposite to alternate. So it will say girls and boys are equal in performance. Okay, girls or boys are equal in performance. This will be opposite to alternate hypothesis, right? So if null hypothesis says girls and boys are equal in performance, then when can we reject the null hypothesis? When can we reject the null hypothesis? Because we have to test the null hypothesis. So when can we reject? If null hypothesis will be wrong. Okay, then we can reject the null hypothesis. So when the null hypothesis will be wrong, if girls are better than boys, or girls are less efficient than boys. If two things will happen, we can say that we have to reject the null hypothesis. So if girls are greater than boys or more performance than boys, so right hand side. If girls are have less performance than boys, then left hand side. So these, in each two cases, the null hypothesis will be rejected. Okay, so in between that, the null hypothesis will be accepted. Okay, so as we are taking both the sides, then this is called two-tailed test. So whenever in two-tailed test, where the null hypothesis will be rejected, when we have maximum value, when we have minimum value. So this is the region of rejection, or we can say this is the critical, these are the critical regions, right? So let's recall what I told about two-tailed test, whether I have to explain again. In both the case, okay. See, in both the case, in two-tailed test, you have to check that the null hypothesis is rejected in both the ends, right? In the right hand side, in the left hand side. How can it be rejected? I just showed you through the graph. So you have, in both the cases, you have to consider null hypothesis and alternate hypothesis. So if your alternate null hypothesis says that girls and boys are equal in performance, your alternate hypothesis will say that girls and boys are not equal in performance. Because alternate null hypothesis always says there is no relation. That means no relation means they are equal. If there is a relation, that means either it can be greater or less or not equal. Okay, so these are the relationships. So using that, you can find out the two-tailed test. Let me show again. Am I clear?
Yes, ma, you're clear.
Okay. Next, start quickly the right-tailed test. These are the hypothesis testing I am saying. So right-tailed test means at the right-hand side, we have to reject the null hypothesis. Why we are talking about null hypothesis? Because in the entire study of data analysis, we have to test the null hypothesis. So what is the meaning of this one? See from the diagram that suppose alternate hypothesis says, okay, alternate hypothesis says girls are, I am taking an example. Okay, so girls are better than boys. Suppose this is the example, girls are better than boys. This is the alternate hypothesis. So here girls are better than boys. This is what, this is our alternate hypothesis. So what will be the null hypothesis here? So null hypothesis will say that girls are not better than boys. Girls are not better than boys. This is the alternate hypothesis. So here you have to test the null hypothesis, and suppose you want to reject that, then when the null hypothesis will be rejected, when the null hypothesis rejected, if H naught will be false, you have written this in H naught that girls are not better than boys. That means if that will be false, this will be rejected. So if the null hypothesis will be false, that means you can say that girls are better than boys. If null hypothesis will be false, you can say girls are better than boys. So girls are better than boys means you will come at the right hand side of the graph. So in the right hand side of the graph here, null hypothesis is rejected. Okay, so if some value of the assumption of the hypothesis value is greater than, then you have to check using right-tailed test. Check means which hypothesis you have to check. You have to check the null hypothesis, right? Then come to left-tailed test. Left-tailed test means at the left-hand side. This is the critical region. This here, the region at where the null hypothesis is rejected. So let's talk about the left-tailed test. Here the alternate hypothesis says that girls are less than boys. Okay, girls are less capable than the boys. Let this is the alternate hypothesis. So if this is the alternate hypothesis, then what will be the null hypothesis here? Null hypothesis says that girls are not less than boys. Girls are not less than boys. If I have to test the hypothesis, I have to test the null hypothesis. So when I will test null hypothesis, if I want to reject the null hypothesis, okay, generally it is tested, null hypothesis tested to reject it. Okay, so when the null hypothesis is to be rejected, then we have to false or falsify this statement. If we make false the null hypothesis, we can say the null hypothesis is rejected. So if the null hypothesis is false, that means this is false, though we can say that girls are less than boys. Girls are less than boys. So if girls are less than boys, so left hand side it will come, and in this case null hypothesis will be rejected. Okay, so if something some assumptions we are having where we can get that some assumption is less than the another one, at that case we have to use left tailed test to test the null hypothesis in this way. Okay, so alternate hypothesis says less than, greater than, null hypothesis not equal, and the null hypothesis says equal. Okay, equal, and more probably it is called less than equal and greater than equal also. Only less than, only greater than, that is the part of alternate hypothesis. Not equal is the part of alternate hypothesis. But if you say about null hypothesis, there is equal, less than equal, or greater than equal. But most probably we use this equal portion and this portion, these three portion, right? So in this way we can have two-tailed test, right-tailed test, and left-tailed test. So are you clear about this? Shall I proceed?
Yes, ma'am. You can proceed.
Okay. Is it boring? Are you not getting bored? Is it okay? Fine. It is exceeded the time limit. That's why I'm asking. Okay, na? Fine. Okay. I have already extended up to half an hour till I need few 10 to
Excuse me, ma.
15 minutes.
I want to ask a question, please.
Yes.
Yeah, ma, can you please send this document to our class captain so that we can go through it?
Sure, sure,
Okay,
sure.
thank you very much, ma.
Okay. Let's see the another one quickly. This is, let's check. Okay. Then the steps of hypothesis testing, right? What are the steps of hypothesis testing? See, after explaining this one, just take the screenshot of the questions. Okay. These are the questions. This is first question. This is another question is there. Just take the screenshot of the questions after the explanation so that you will be able to answer. And in the next in practical classes, you can show me the answers also. Okay. So these are the steps of hypothesis testing, right? So whenever we test our hypothesis, that means we can say that analysis is a process, right? So we do not do everything in one step, or we cannot do everything in one step. So we have to cover so many steps to succeed, right? So in case of hypothesis, if we have generated the hypothesis, how can you test? We have to first of all write the null and alternate hypothesis. Then I have to find the level of significance. This level of significance is called alpha. This is called the error level also. That means in your finding, in your assumption, what is the percentage of error. So if you are saying that there is 5% of error, so generally the alpha level is 5%, 1%, or 10%. Okay, so if you are saying in my experimentation, in my assumption, there is 5% of error, that means you are confident that the confidence level is 95%. That means you have 95% correct things in your analysis. If your alpha level or the level of significance is 1%, that means you are assured that your study has 99% correct data, right? So this is called the level of significance of the alpha level, that says that in your study what is the percentage of error. Okay, as you are collecting data, as the human is collecting the data, so there may be the chance of error. So what is the level of significance of the error factor? That may be 5%, that may be 1%, that may be 10%, right? So the opposite one will be the confidence level or the true value in your experimentation. So first of all, you have to write the null and alternate hypothesis. Then you have to set the level of significance. Then you have to say which test you have to conduct. Okay, so in our hypothesis testing, we can have a Z test, we can have T test also, we can have H test. I will explain all these things. We can have a U test also. These are the names of the test that is used to perform on the hypothesis generated, right? Then you have to find out the value. After the testing is applied, you have to find out the value. So whenever you get the value, you have to test that using the table value. This can be obtained from the internet, table value. Then whenever you will get the table value and the expected value, you have to compare. So if the compute value is less than the table value, you have to accept the null hypothesis. If the computed value is greater than the table value, you have to reject the null hypothesis. This is the entire procedure. So now we will see one by one how we can do that one. Okay, so are you clear about the level of significance, the alpha level? Various types of test we have, that is Z test and T test. Let's see what is
Yes,
T
it is
test.
clear.
Okay. Yes, you want to ask something? Let's see what is T test and what is Z test. Suppose the sample size is small. Okay, the sample size is less than 30. We have collected the sample, we are making the assumption. If the sample size is less than 30, we can apply T test, we can apply we can apply T test. Okay, so if the sample size is less than 30, we can apply T test. And if the sample size is greater than 30 or equal to 30, we can apply Z test, right? So in case of T test and Z test, then we have to compare the mean of the samples. Okay. In both the cases, T test and Z test, we have to compare the mean of the two samples, and the sample size is very small. What is the sample size? In case of T test, sample size is less than 30. In case of Z test, sample size is greater than or equal to 30. So in case of Z and T test, you can see this is the T test, right? So sample size is very small, that is less than 30. And population variance. Population variance means the standard deviation. The standard deviation of the population is not known. We do not know the variance in the population. That is called the T test. So if you talk about this, you can see the sample size is less than 30 and standard deviation is not known, standard deviation of the entire population, right? So if the sample size is greater than or equal to 30 and the standard deviation is known, that the test we have to perform, that is called Z test, right? So in case of T test, the samples are randomly selected and the sample we have the quantitative one. That means the numbers we have to test, and normal distribution should be there. That means whenever we plot the data, it should give a bell shape. And here the samples we have to collect, the sample size should be less than 30. Okay, this is the formula of the T test. formula of the t-test. This is called, M stands for mean, mean of the sample. This M is what? This is the mean of the sample. The samples you have collected, the mean of the sample. Mu is what? This is the mean of the entire population. Okay. S stands for standard deviation of the sample. You have to consider the standard deviation of the sample, right? And square root n, here n stands for the number of items in your series. So using this, you can find out the t-test, and whatever the data you have to consider, the data should be less than 30 in sample, and the numbers you have to consider, so that you can put the formula, right? So that's why it is quantitative one, and that should be the normal distribution, and sample size should be less than 30. So in case of both T and Z test, we have to compare the mean, okay, mean of the samples. So the things I explained, this is written, Z test and what about T test. So here from an example, you can see that suppose we have a problem, right? Here the example how we can apply the t-test and z-test here. One example, suppose we have a problem to compare the dietary intake, the mean of the dietary intake of individual. Means whether the individual is taking diet as recommended, whether the woman on an average is taking the diet as recommended. This is our problem, we have to find out. Okay, so here the we have to consider 11 healthy women. That means the sample size is less than 30, less than 30. So which kind of test I have to apply here? I have to apply here t test, and also I have to find the mean. So both conditions are satisfying, that I have to find out mean, and the sample size is 11. That means it is less than 30. So I have to apply t test. So in case of t test, this is the formula, right? This is the formula here. So how can we apply? See, this is the average daily intake. Average daily intake is given. Okay. So here in the question, it is also given that mean of this ADE, this is average daily intake, the mean of the above is calculated as, it is given also 6753.6, and standard deviation of these all these three after subtracting from male and finding the square root and dividing by these all 11, the standard deviation is also given as this much. So in question it is already given, and you can see that the intake, the average intake of the woman is given as 7725. That means this you can see the value, the value of mu, the value of mu is also given, right? So this is the value of mu, this is the value of mean, and this is the standard deviation. And what is the value of n here? This is n is 11. So everything is given. So as you know, we have to apply the t test. What we can do, that the formula is, here you can see everything is given, right? So the formula is here, t test m. M means the mean of the sample. So mean is given as 67536 minus, what is the mean of the population? It is given also 7725, right? Then what is the standard deviation given? 1142.1 divided by square root of n. N means how much? It is 11. So when you will solve this one, you will get minus 2.81, right? Minus 2.81. Okay. So this is, everything is given. Mean of the sample. Okay. Mean of the sample, that means M is given here. M is given. This is standard deviation. S is given. N is given already 11. We are told that 11 healthy women is to be considered. And this is the entire mean of the population is given. So everything is given, and you know, as you are finding out the comparing the mean, and the size of the population is less than 30, that is 11 only. So you have to apply t test. So whenever you apply t test, you just received the answer as minus 2.81. Okay, listen carefully, minus 2.81. Okay, then here that you applied, here we are testing the hypothesis. Okay, through the problem we are testing the hypothesis. So when you are testing the hypothesis, first thing was that you state the types of hypothesis, null and alternate hypothesis. So in this example, we can say that our null hypothesis is there is no difference between the population and sample, means yes, the women are taking intake as recommended. This is my null hypothesis. Then I have to say the alternate hypothesis. So from this example, what is my alternate hypothesis? That there is a difference between the population mean and the sample mean. That means all the women are not taking intake as recommended. So first of all, I set the null and alternate hypothesis. Then we have to set the level of significance. Let in my study I have the alpha level as 0.5. Here it is written. Let it is zero point 0.5. Okay. So alpha level is 5%. 5% means 0.05. So this is my alpha level. So alpha level means the error level. So what will be my confident level? This will be 95%. Right? So I have just to find out the H1 and H0 what will be. Then I set the alpha level. Then I found the which test I have to perform. So I just selected it will be T test and I performed the test. Here you can see I performed the test here. Which test I have to use? T test. I find out the value. What is my value? Minus 2.81. This is my value. So after getting the value, I have to compare that, or I have to find the table value also. So I told that table value can be obtained from internet. So here I have plotted the table value. This is one of the part of the table value. Okay. So degree of freedom and this is the percentage of significance level is given. I obtained the value as minus 2.81 after the t test. This is my computed value. Computed value. Then after getting the computed value, I have to find the table value. Okay, then I have to compare the computed value with the table value to check whether the null hypothesis will be accepted or rejected. So first of all, I computed the value from the t test. Then my alpha level is 5%. 5%. That means I have to check this one. Okay, I have to check this one. Then which part of this, the degree of freedom will be considered? So the degree of freedom will be n minus 1. So what is our n? Our n was 11. So 11 minus 1, it was 10. So I have to check this 10 and this 5%. Okay, this 10 and this 5%, because our alpha level is 5%. And we got the degree of freedom as 10, because in every test you have to find the degree of freedom to find the table value. So our degree of freedom is 10. How did you find 10? Because the number of samples we have 11. So 11 minus 1, that is n minus 1, it is 10. So 10 for this, the significance level is 2.228. So the value I received, that is minus 2.81, and the table value is 2.228. So which one is greater? That my here computed value is less than my table value. If the computed value, this is the computed value I computed from the t test, and I got the table value as this one. So as my computed value is less than my table value, so the null hypothesis is accepted. So if in your result you are getting the computed value as less than or equal to the table value, you have to accept the null hypothesis. Otherwise, you have to reject the null hypothesis. So this is all about the testing of a hypothesis. Yes. Write your question in the chat box, please. Yes. Okay. Yes. Then see, yes, I just let me explain that whether you are using t test or whether you are using g test, that it depends upon the sample size you are using. So whatever the value you will get, the process of testing the hypothesis will be same. and this will be the table, and you have to get the significance level when you will actually test. This is the theoretical person. No? When you will actually test, you will have the significance level. Okay, so if it is 5%, you have to let me show. If it is 5%, you have to see this one. If you have the significance level at 10%, that may be t test, that may be g test. Will be, you have to see according to that. If your significance level at 2%, you have to see these values to find the tabular value, right? So this will be same for any kind of test you have, but it depends that whether you are using the t test or the g test, right? This will be same. Okay, am I clear now? Okay, I just gave an example of t test, right? So you can apply this method for the g test also. So wherever you will get the g test value, that means the calculated value, you have to compare with this table. The table of this significance will be same for all, but that depends that whether you are using the g test or the t test. So according to that, you have to use the degree of freedom, and you will check. So in my case it is 10, and this is the value, tabular value. It may differ in other cases also, so you have to check. So I have just shown a part of this one part. This is not the entire table. I have just interpreted a part of the entire significance level. So if you will search, you will get much lengthy table, but I have just shown a part of the significance table or degree of freedom. So that's why it is showing up to 30 only. It is not limited to 30, it is much more than that. Okay, so the most important part we have covered. And see, another thing, that is the life cycle of data science, right? And see that if you say the life cycle of data science, you can have that it has problem, business problem understanding. It has data collection, data cleaning, processing, and it has also, you can see, the exploratory data analysis and modeling. Also it has the deployment. So total 6 life cycles are there in the data science. So as we can explain that, first of all, we have to understand that we have to identify a problem, right? So there was a question in the previous class that what is the first step of data analysis? It was identification of problem. So first understand what do you want to do? What is the purpose of data analysis? What is your aim to analyze the data? Okay, so this is the problem, business problem identification. So you know it very well that in data science we extract data from various sources. That means there is the big data we need. So I have to apply algorithms like KNN, K nearest neighbor algorithm, a priori algorithms, naive Bayes algorithm, everything else to predict the pattern, to predict the trend, etc. So we analyze the data, process the data, and deploy the data to get the required requirements, right? So this is the business problem identification. So second one is called data collection. So after understanding the purpose of our data analysis, we have to collect the data, right? We have to collect the data. So here you know that we have so many times discussed in the class, the data we want to collect, that should be right to our analysis. That means we should collect those kind of data that are fit to our analysis. The data should be reliable one, the data should be correct one, and the data should be complete one. Okay, so there should be quality in the data so that we can have proper data for the analysis purpose. Then third one is called data cleaning and processing. So after data collection, we have to process the data, we have to extract, we have to transform the data, we have to pre-process the data, we have to load the data in data warehouse. Everything we have to do, that we have to clean and process or pre-process our data, right? So next thing is called EDA. EDA is called exploratory data analysis. So it is what it is used by data analysts to analyze or investigate the data sets. summarizes the main characteristics. That means we have to inspect all features, we have to define the properties, we have to build confidence, everything. That means we have to measure each and every features, each and every characteristics of the data. We have to summarize the main characteristics. Okay. And we have to visualize the data. The data visualization means we have to represent our data in the form of chart, graph, and various softwares like Power BI, Desktop, R Language, Google Map. Everything we have to use to represent our data. That means it will make easier to discover the pattern. We can spot the anomaly. We can check the assumptions also. So the data analyst reveals all the features you can have in the data that is being processed to determine the variables and the relationship between them. So this is called the exploratory data analysis. We have to explore all the features of the data to get our better decision, right? So next one is called model building. Model building means after the exploring all the features, we have to build the model and its performance is evaluated. Like, so in case of whenever you build a model, you need a kind of data which we called as training data. So entire data set is of two types, right? So you can see uh, entire data set is of two types, right? So training data and testing data. So here training data is what? It is the subset of the original data that is used to train our machine. Suppose this is the machine, we have to generate a model, we have to create a model, we can use that, we can train that model, or we can generate that model using the training data set, right? So whereas the testing data is what? Testing data is used to test the accuracy of the model. We have to generate the model, we have to prepare the model using the training set, and we have to test that, we have to test the accuracy of the model using the testing data. Okay. So when we predict something, that depends upon what data we have taken, because if we have accurate input, if we have quality input, we can have the accurate output. So prediction is highly depends upon the quality of data. So if we have the training data set perfect, that means we have the proper pre-processed data, the training data set, and we are generating a model, then we can have that our model is working properly. So training data is known as to the model, and testing data is known to the is new to the model. It is used to check or the uh, test the accuracy of the model, right? So as you know, there is supervised, unsupervised method of creating the data model. So for unsupervised learning method, the training data contains the unlabeled data. Supervised means there is a supervisor and he knows what to do. But unsupervised means there is no supervised. We by ourselves we have to check all the features one by one. Then we have to predict yes, this belong to that set. Okay, this is the unsupervised one, right? So for unsupervised learning, the training data contain the unlabeled data points. That is, inputs are not tagged with the corresponding output. So models are required to find the patterns from the given training data set in order to make the prediction. And it is not in case of supervised learning, because on the other hand, for supervised learning, the training data contains the label that in order to train the model, and you have to make the prediction, right? So these are the case of supervised and unsupervised data sets of model generation. This is already the data is labeled, the input is according to the output, it is properly mapped. But in case of unsupervised, it is not mapped, we have to give much more data, and the model will compare the all the features of the data given and will say that this data belongs to this category and that data belongs to that category. So this is called unsupervised method of data model building, right? So after that, the last one is when you generated the model, that may be using supervised data, that may be using unsupervised data, you have to deploy the model. So now after model development is the time to deploy, to check whether this is productive or not. So you have to test the model, you have to monitor the performance of the model. Okay. So this is the entire case of data science life cycle, the entire thing that happened during the data science analysis. Okay, data analysis process. This is the thing. So, am I clear, students?
Yes, ma, you are clear. You're clear.
Okay.
Yes, you are, ma.
But we have to, exactly. That's why I we requested you to share the document to
Okay.
the class captain
Sure.
so that we can go and
Yes, yes, it is
look
needed to go
through
through
it again.
again because it
Yes.
will be a refresh recap of the thing that I explained and you will study. It will be better. Very good. Okay. Then see, mm, 1 second. Okay, here one more thing you have that is called data visualization, right? Data visualization. So in case of data visualization, what happens that you have to visualize the data, right? Visualize the data. That means whenever we collect the data, we have so many types of data. So if we'll just represent you the data that I have collected, it may not be so fruitful that you will just read out the data and you will get the data, you'll get the analysis. So if I can represent the data through the visual element, that is represent the data through the graph, through the chart, through the various maps, it will be easier for you to extract the knowledge from the entire data set. So that's why we need the data visualization process or various graph or charts to visualize the data, right? So that is the question of data visualization. So what are the things or what are the tools or what are the types of chart you know? Can you tell me the types of various graphs for data visualization? Please. Okay. Okay. Any other students? There are bar graphs, there are line graphs also. You can have, there are histogram, pie chart, scatter plots, heat map, radar chart. You can have the funnel chart also. So many things are there so that you can visualize your data. So let me show you. Uh, One question you have, just make sure that you can answer what is the difference or how can you differentiate or what is the difference between data science and machine learning. Okay, so you have studied machine learning and you have just explained you data science. So what is the difference between data science and machine learning? This is one of the question for you all. So did you take the screenshot of the questions on probability that I told that during my explanation of probability testing, you have to take the screenshot. Did you take the screenshot?
Yes, ma'am.
Now the first question you have considered, the second one, I'm just asking this one. Okay. Let me show you again. So Bayes theorem is everyone is clear about that? Then. Okay. Yes, yes. Okay. Okay. see that data science and data analytics, that means see that you can see the data analyst, right? Data science and data analyst, or you can see the data engineers, or you can see the business analyst. So many things are there, right? So if you see the difference between data, see what is data analyst. See that data science, you can see it is the umbrella term for all the aspect of data processing, from collection to modeling to insights, everything else. On the other hand, if you take the data analytics, is mainly concerned with the statistics, with the mathematics, with the statistical analysis. Okay, if you consider data science, data scientist, data analytics, or data analyst, so data science is a entire thing. That means it is from collection of data to modeling of data to taking the insights of data. But if you take about talk about the data analyst, it is concerned with the statistics, mathematics, and statistical analysis. So it will focus on only the data analysis. While the data science, if you consider, it is related to the bigger picture around the organization and data, right? So in most of the data workplaces, that data scientist and data analyst work together. Okay, so in most of the workplaces, both the data scientist and data analyst work together with a, or you can say, the common business goal. But a data analyst may spend much more time on routine analysis, providing regular reports, etc. And the data analyst may design the way the data is stored, the manipulated, or analyzed. Means simply put, the if you say the data analyst makes sense out of the existing data. If there is the existing data, what it can be done, where it can be stored, how it can be manipulated, how it can be analyzed, everything is done by the data analyst. And where the data scientist is, that it creates a new method and tools to process data for use by the data analyst. That means data analyst just processed that this is the existing data, how the data can be stored, how the data can be manipulated, how it can be analyzed. And the data scientist will create a new method or tool to process the data that is provided by the data analyst. So both are, means like the two parts of a coin, both profession is very important. So it depends upon the which one you choose. Okay. Okay. Next. Okay. So next one is called KDD. KDD means what? Knowledge discovery in database, right? So this is called knowledge discovery in database. That means we have a database where we have to put knowledge after discovery. For this, we need so many processes. So as we know that here you can see, as we know that for analysis purpose, we collect data from various sources, and those are different and huge. So from the entire data set, in order to extract the useful knowledge or knowledge required by the user, we need a few steps that we call as KDD. So it is used to identify, you can say, you can identify the hidden patterns. Here the hidden patterns, the relationship among the data, a relationship between past and future of the data, or we can say that if these things have happened in last 2 years, in future these things may happen, right? So it helps to infer something. We can have some data, if we analyze the data, we can infer something, it predicts something. So it is used, the knowledge discovery database, the process it have, these processes can be used in various domains, in various fields. That means where the knowledge is needed from the raw data. That means it can be used in finance, it can be used in healthcare, it can be used in transportation, in everywhere. Whenever we have to process knowledge from the entire data, we need various processes that we combinedly call as KDD, right? So these are the processes it has. uh, Okay, these are the processes. So first thing is called data selection. So data selection is means what? This is the data selection portion. So what is the meaning of this one? We have to identify and select the relevant data for analysis. It involves means you can choose the relevant data sources. You can collect data from various sources that is required for the data analysis purpose. So first of all, you have to select the data. Then you have to pre-process the data. You know much well about the pre-processing. That means we have to clean the data. We have to remove the missing inconsistent data. We have to make it relevant for our analysis purpose. Then after that, we have to transform the data. So we can transform that, we can aggregate the data, we can normalize the data, we can discretize the data that we have discussed in the previous class. So using all these methods, we can transform the data to a particular form so that our algorithm that I want to apply to data analysis purpose, that algorithm can easily access the data. Right? So after that, I have to mine the data. I have to find the knowledge from the existing data or from the transformed data. Okay, so it is the heart, the data mining process is the heart of knowledge discovery database. So it involves that various data mining techniques like association, like regression, like clustering, like k-means algorithm, like a priori algorithm. So you can use the naive bayes algorithms. Various algorithms can be used to mine the data, to find the pattern, to find the trend from the pre-processed data. So after that, we have to evaluate. So pattern evaluation means what? After data mining, the next step is to evaluate the discovered patterns to determine their usefulness. So we have, after getting the pattern, we have to evaluate whether the patterns or the trends or the data we receive that is useful or not. We have to find the significance of the patterns, right? So after that, there is a knowledge representation. This is what? This is the knowledge representation. So this step says that we have to represent the knowledge extracted from the data in a way that the human can easily understand, because everything is going through a process. So as we have received knowledge at the end, we have to represent that in such a way that the humans can understand and can use for their purpose. So for that, we use various visualization reports, various communication reports, various insights we can have. Then after the knowledge representation, we have to deploy the knowledge. We have to make our knowledge available for the practical applications. So these are all about the knowledge discovery in database, right? Clear, students?
Yes, ma, it is clear.
Okay. Okay. So if you want to ask me anything, you can ask. Yeah, yeah, yeah. Yeah, practical classes are starting from 17, right? 17th of June. Yes, at that time we will see. Okay. So see the last one don't take much more time. The last one is data visualization, right? So data visualization means, I told you that we have some complex data. In order to make that understandable, in order to make that accessible easily, so we have to use the visualization tools. That means we have to make our data represented in such a visual element so that we can easily get the data, or we can easily get the understanding, or we can easily get the insight that we need. So that's why we are using the data visualization. Generally, we have to visualize the data through various visual elements, through various chart, various graphs, etc. So if we are using the data visualization, what can be the advantages? It makes the data more clear. We can easily understand the data if we are representing the data in a visual form, in a graphical way, right? So If you are representing our data in a graphical way, we can also generate the insights. That means we can easily get the data, we can easily discover the data that can be used for the data decision making purpose, right? So if you are representing something in a graphical way, it becomes much more effective for the communication, because if anything is written in a paragraph, and if same thing is represented using suppose using chart or using graph we have represented, then it will be much more effective than the paragraph one. So for the effective communication, we can also use the data visualization, right? Then next advantage is the storytelling. Storytelling means visualization always tells you everything. That means whenever you see some graph, whenever you see some chart, it says you much more things which can be easily understood without having any professional knowledge, right? So this is called storytelling. Then another advantage is we can have quick identification of those anomalies. Outliers means the unmatched data, the data that is not, that doesn't form any cluster, that doesn't have similar data. That means the data which is not original one, we say that it's the outlier. So we can easily identify the outlier, we can easily identify the anomalies using the data visualization per process. Okay, so if we visualize the data, if we represent the data, that means we can have a better comparison. We can track the performance also. So it increases our benchmark, and we can also have the better comparison. Okay. So if we have represented data in a tabular form, in a graphical form, it helps us to make decision, helps us to take better decision, and we can also explore various things. Okay, and we can also make the data much more interactive if you are using the interactive data visualization tools like Power BI desktop, right? So few other disadvantages, that means misinterpretation. If you say that if your table or if your data visualization tool that you are using that is poorly designed, that means if the input is bad, your output is also bad. So if your visualization is very poor, you cannot say that you will get the proper knowledge from the entire graphical representation, right? So next disadvantages can be complexity. That means if you have complex data, your graph also look like complex. That means there should be complexity, and the graph that is complex, that is not suitable at all for effective communication. And if we have limited contents in the data, or if we have limited data, then we cannot have a proper graph or proper representation, from where we cannot have a quick decision for business analysis purpose, right? And the data availability means if the data for using that we are plotting the graph or chart is incomplete or inaccurate, then we cannot also have a better understanding from the graphical representation. So these are the advantages and disadvantages of data visualization. Okay, so same thing it is shown here, that when we have a big data, it can hide trend or pattern. That I told, if something is written, it hides trend and pattern. You cannot just easily find out what the graph or what the chart, the paragraph wants to say us, because we can have a huge data. But if the same thing is represented using the visual elements like graph, like chart, everything else, it will be easy for you to get the information and the data easily, right? So these are the benefits of taking the data visualization. So the data visualization can have, we can have the data processed faster than text and other reports. We can also easily identify the relationship. If you will get the line chart, you can also get the trend over years. That means what was in the past, what is now, what can be in the future, you can also find out. Okay, so you have to find out the relationship, you have to find out the trend, we have to find out the pattern, right? Then people using the graph or chart can have the better insight, can means they can represent their data in such a way, in a very attractive way, without having any professional or coding skills, right? So you can have better action or better decision making capability from the data if that is represented in a graphical way, right? So these are the benefits that we can have if we have data visualization. So meaning of data visualization means simply you are representing your data in a graphical way and what are the benefits you can have. Then how to create an effective graph? First you have to define the information, the data upon which you want to draw the graph, right? And after that you have to choose the most means useful chart or most useful graph or how you want to represent. So always don't say that I need a bar chart or I need a graph chart. You have to select the chart that looks very attractive, that will easily represent your data, that will attract the customers to get knowledge easily from the graph. Okay, then after that you have to focus on the graph. You have to use the various means suppose you are using x and y axis, you have to arrange the data in such a way that the graph will look like very attractive, to look like very informative, right? So this is this point. And the second last one is called do not try to include the complex data in the graph, because if you are using the complex data your graph will also look like the complex one. Okay, so always try to make your graph or chart or the data visualization so simple, so clear that everyone without any coding skill can easily get the knowledge what they actually need from the data. Then you can use various kind of graph that generally present in the data visualization process. Okay, you have to make your chart simple and easier to understand. Do not use so many symbols so that anyone if it is looking for at your data visualization process, he or she can easily find out that what you want to display through your data visualization uh, graph or data visualization elements, right? So these are the things. Then you can have so many types of data visualizations process are there. Line graph, you can have line graph. So line graph tells what the line graph will look like this line graph. So this says this utilizes the points and lines. These are the points, this is the points and these are the lines. That means this is the graph that utilizes points and lines to represent the change over time. That means in 2012 the product was this product A, the value was this much. In 2013 the value became this much. In 2014 the that value became this much. Okay, so it is used to represent the change over time. So it represented through the line graph. So it is a graph that shows a line joining the several, it is joining the several points or lines that shows the relationship between the points, how the points are related. Because in 2012 this was the value, let it is 19. In 2012 the value became 91. So what is the relation, whether the value is decreased or increased? So it shows the relationship between the value over the period of time. Okay, so this is the line graph. Next we have bar graph. So bar graph is what, this is the pictorial representation of the data. We have to group the data. Here you can see that we have product A, product B, product C, and we have represented using the means the horizontal bars, or you can show the data using horizontal or vertical bars. Okay, so the volume or the you can say the width of the bar depends upon the volume of data. So if you have much more data, your the width of this bar increases, like so the chart's horizontal axis, it can represent the categorical data or the discrete data, or the vertical axis can represent the discrete or the categorical data. So it depends upon the analyzer, how the analyzer want to analyze the data or how he or she wants to represent the data. So this is called bar graph. Next is called column chart. See, column chart is same as the bar chart. This is a part of the bar chart. And if that it can show you a situation at a point, that means it doesn't emphasize on the trend. It say the total amount. What is the value of the product A at 2012? This will show the value only. It won't say that in previous year its value was this much, in after 1 year the value is this much, after 2 years the value is this much. It won't say the trend, it will say the total value. Okay, it looks like the column bar chart also. So this is the column chart. This says that at 2019 the value are this much. It won't say the relationship between the values, or it won't say the trend over the years, right? Like the line chart. Next, about the pie chart. Pie chart, you all know that it is an you can say used to represent the numerical proportions of a data set. Suppose we have a data set, we have to represent the numerical proportion, we can use the pie chart. That means this is the 40% expense, suppose, and this is the 10% expense, suppose, this is the 10% expense. On rent, let it is on rent, it is on clothes, it is on you can say it is on study. Okay, so these are the proportion of the entire data set. The whole thing is divided into number of proportions, and we can represent that using the pie chart, right? So next is called area chart. So these are called the data visualization tools or charts or techniques that we can use. So area chart is what this represents the change of something over time, like the line chart. The line chart or line graph also says something is changed over time. It was connected through the line. And same thing, area chart also says that something is changed over time. It will also show you the trend. But the difference is that in area chart, the x-axis and the line is filled with a color. It will look like this. It will say the total volume also. See, it will look like this. This is the area chart or area graph. The line graph will not look like this. They will just join the points with each other and through the line. But in case of your area graph, the area will be filled. Okay, so the x-axis and the volume will be filled. So it also says the total volume in a particular year. Right? So next is called scatter plot. So scatter plot, it will look like this. That means it is a type of plot using various Cartesian coordinates to display the values of two variables. It will use the coordinate to display the value of two variables, right? So it can use that, it can be displayed using the number of or the collection of data points. These are the data points. These are collected and are plotted in the Cartesian coordinates or x and y axis. So the position on the horizontal axis determines the value of one variable, and the position on the vertical axis. Okay, the position on the vertical axis determines the value of another variable. So why you use the scatter plot? So scatter plot is used when